This is a LovattPhysics video for IB Higher Level, Unit 11, on generating domestic electricity. If you have a generator, it is generally made of a coil of wire and a permanent magnet. This is a kind of basic generator here, and here we have the coil of wire here, and that rotates within a permanent magnetic field supplied by the magnet here, and an EMF is generated in that coil of wire because of the changing flux that goes through the coil, and because there's more than one turn, we call that the changing flux linkage. Now, the EMF generated is actually equal to the rate of change of flux linkage. So we can have EMF is the rate of change of the flux linkage, which is given by NBA cos theta, where N is the number of turns in the coil, B is the magnetic field strength of the permanent magnet, and A is the area of one of those turns of coil, the area inside the turn. So the EMF generated is the rate of change of magnetic flux linkage through the coil. Now, if we go back to our generator here, you can see that it'll be very difficult for me to generate electricity by changing the number of turns of the coil because it's a fixed number. Same with the permanent magnet. This is a fixed permanent magnetic field, so it's hard for me to change the magnetic field. And the same with the area of the turns. It's going to be hard for me to make it bigger or smaller. But cos theta is the angle that the magnetic field is penetrating the coil at. So as I rotate the coil, that theta is changing constantly, and because there is a constant change, that means there is an EMF generated. So cos theta is the variable that's changing, so we can rewrite our equation as the EMF is equal to NBA times the rate of change of cos theta. So what would we be expecting from a graph of that? Well, if we've got the rate of change of cos something, that gives you negative sine. So we would get the EMF is equal to minus sine theta NBA. And so we'd be expecting a minus sine graph. So we'd be expecting it to look something like that. So if we then speed up how fast we're rotating this coil, if we get faster, two things happen. Number one, the frequency of the sine wave will increase. So we will go from that to something like that, increased frequency. But also the rate of change of the angle is increasing. So the EMF will also increase. And by EMF we mean the peak here, the maximum. And so what we will actually get is not the blue line, but the red line. Now notice that both the height of the waves has increased and the frequency has increased. We could also increase the EMF by increasing the number of turns, by increasing the strength of the magnetic field, or by increasing the area of the turns of the coil. But most commonly in exam questions is this one. If you turn the coil faster, then not only do you increase the EMF, but you also increase the frequency of the generated electricity. Now we can see this on an oscilloscope. An oscilloscope is a device that shows us the shape of a wave, so that's what's happening here on the screen on the right. Now you can see that when I start to turn the generator, it creates a wave, and the peak of that wave is quite low because I'm going quite slow. So the EMF generated is relatively low. If I speed up, you'll notice that not only does the peak of the wave increase, the maximum EMF generated increase, but also the frequency of that wave is going to increase. So if I speed up like this, see the peak has got much higher, but also the frequency has increased. Now that change is a very common exam question, and you should be very familiar with why that is happening. Now if I slow down again, then those peaks drop back down, So the maximum EMF generated is lower again, and also the frequency has decreased, and I can keep going slower and slower, and the peaks keep dropping and the frequency decreases until we stop. That was a LovattPhysics video about generating domestic electricity and how to increase the EMF. If you liked it, please like the video. Feel free to ask questions in the comments underneath. And if you want to see more, please subscribe. Thanks very much.